Hi, Algebra 2 students. Today we're starting section 8.2 where we're going to learn about the law of sines and law of cosines, which means we're going to be talking about triangles that are not right triangles. In the first day here, we're going to focus just on the law of sines. Before we begin, let's look at a real-world application problem for the types of things we'll be looking at. It says a biologist measures the slant height of a conical termite mound to be 32 feet. The angle from the ground to the top of the mound is 51 degrees, and the base of the mound has a diameter of 40 feet. Okay, so they're saying the slant height to the top of the mound, so this angle is 32 feet, because part A is wanting me just to draw a picture. Okay, so that's what I'm working on here. The angle between to the top of the mound is 51 degrees, and the diameter across the mound, so from here to here, is 40 feet. Okay, I can complete the triangle, and it looks like that. Okay, so as we talked about, we're not necessarily going to be looking at right triangles anymore. Having said that, this says make sense and persevere. What is the height of the mound? Okay, so we could actually use what we've been doing, cut this down the middle, which then creates a right triangle. The height is that middle line I just drew. Now, if I was just looking at this triangle, this would allow me to use just regular SOHCAHTOA because I am using a right triangle. The opposite side of the 51 is x, and the hypotenuse is 32. So for part B, I would use the sine of 51 degrees equals x over 32. I would multiply both sides by 32, and I got x equals about 25 feet. So it's about 25 feet high. I did round to the nearest whole number. Okay, so we started with a situation that wasn't a right triangle, but then we created one. This idea of taking a non-right triangle and turning it into a right triangle, we're going to see when we introduce the idea of the law of sines. I'm just going to talk through this proof. You will not have to be able to prove it, but it is important to know where things come from sometimes. So if we wanted to derive the law of sines, you can see we started with a non-right triangle, triangle ABC, and then we did what we did in the last example. We drew in the height or the altitude, and we called that x. Once we do that, we could say that the sine of A is opposite, which is x, over B. So that's where they got this. Or if we wanted to go from, so then we could multiply both sides by B. That's this side. The other thing they're showing, though, is that we could start from angle B. Sine of B is x over A. So that's how they got the second one. And again, if they multiply both sides by A, they get A sine B. Now, both of these situations are equal to x. So anytime they're equal to the same thing, we can use substitution. And down here, we'll see we can set those equal to each other. As a result, we learned that B sine A equals A sine B. And then this next step just shows that we could divide both sides by A times B. If we do that, the B's in this one's cancel and the A's in this one do, which is how I'm left with sine of the angle A over side length A equals sine of angle B over side length B. Okay, so we see at the bottom the ratio of the sine of an angle to its opposite side is the same for all angles in the same triangle. Okay, so this right here is the law of sines that we're going to be using in this section. So I would get this down in my notes now. In any triangle ABC, what we just learned is that the sine of the angle over the side across from it. Okay, so you need to know the small a means it's the side across from the angle, is equal to sine of angle B over the side length across from it. Now, sometimes the law of sines gets a little confusing when you see it written formally because it actually adds in sine of C, angle C, over little c. Now, at any given time, you're only using two of these fractions. Okay, so you'll either have the sine A over A equals sine B over B. You could have sine B over B equals sine C over C. You could have sine A over A equals sine C over C. But when we write it formally, we do put all three fractions. But again, when you're solving this, you'll never have three at the same time. And again, it is important to know that if this is angle A, side length A is across from it. If this is angle B, side length B is across from it. And if this is angle C, side length C is across from it. The last thing we need to know about law of sines before we put it to use is when do we use it? Use it when given. The most common times we use it, or the most straightforward times I should say, is if we're given ASA. That means angle, side, angle. An example of that would be given side A, or angle A, angle B, and then the side length between. Okay, so angle, side, angle would be the angle with the side between them given. Okay, so that's one situation where you have angle, side, angle. You should have learned about that in geometry. Another time we will use it is when we're given angle, angle, side. Okay, so that's where you're given two angles in a row, so like A and B, but one of the other side lengths, either angle A, or side A, sorry, or side B. Because if I went angle, angle, side, that's correct. If I went the other way, this is angle, angle, side. So pretty much anytime you're given two angles and a side length, then you'll use the law of sines. Now, having said that, the last one, this one I'm going to put some stars around. It's SSA. And yes, if you read it backwards, it's a bad word. Okay, so some people say that. But side, side, angle. That means if you are given two side lengths, so like in this case, C and then rotate to A and then an angle. Okay, so if you're given two sides and an angle that is not between them. Okay, so also if I went the other way, let's say I was given side lengths A and C, but side angle A, that's also side, side angle. Okay, if I was given C and A, but then angle B, that's side, angle, side, that's something different. All right, so the reason I put stars around it though is because this is going to be called the ambiguous case. So we'll spend a lot of time at the end of this lesson. There we go, I spelled it wrong. Ambiguous case. We'll spend a lot of time at the end of this section talking about what the ambiguous case is. We're going to start though by focusing on the two situations that are more straightforward. So let's look at an example. In triangle FHB, the measure of angle F is 40 degrees, measure of angle H is 110, and the length of B is 400. We want to know the length of side F. So anytime you use the law of sines or cosines, we're going to draw a picture. Remember, these are now not right triangles. FHB. Okay, so whenever they give me the letters, I put them around the triangle. Then I label what I know. Measure of angle F is 40 degrees. Measure of angle H is 110 degrees. And finally, measure of angle B, or side length B. Remember, little b has to be across from big B. So this is side B. It has to be that one. Okay? Now, it wants to know the length of side F. So side F would be across from angle F. Before I start, and again, this will become more important tomorrow when you start learning about the law of cosines as well, I first figure out what do they give me. And this is a situation where they gave me angle F. They gave, so an angle, they gave me a side between, and then another angle. So this is a situation where it's ASA, which means I will use the law of sines. Okay, so let's see how we use it. Again, with the law of sines, I take the sine of one of the angles. So I'm going to take the sine of 40 over F. It's always the side across from it. And that's what I'm trying to find. Now, be a little bit careful with the law of sines. I can do this, but if I use the angle they give me, sine of 110, I would have to put that over this length, which I don't know. So then I'm stumped because I'm confused as to how I would do it. But now I remember geometry once again. I know that the three angles of a triangle have to equal 180. So since I know two angles, I am always able to find the third. I take 180 degrees minus 110 degrees minus 40 degrees. When I subtract those three from each other, I get 30 degrees. So this final angle has to be 30. So I don't actually use the 110 degrees in my law of sines. I have to find this 30. Because now I can say that the sine of 30 degrees over 400, the side length across from it. So you want to make sure you're working with the angle or finding the angle across from the side length you're given. Now here's the nice thing about when you're working with two fractions set equal to each other. Because that's all it is a fraction equal to a fraction. This is the situation where we can cross multiply. Okay, so I have F times the sine of 30 equals 400 times the sine of 40. I would make sure my calculator's in degrees, and then to divide, I would just divide both sides by sine of 30. So my answer, when I typed all that in, I got about 514. And we're not talking about anything in particular, so I just put 514. If it was a word problem, which you'll see quite a few of, you'd want to label it. Now I'm going to show you my calculator just so that we're also practicing typing this in. Now that we have our calculator pulled up, again, it's important to know, especially if you're using the online one, how to convert back and forth between radians and degrees, because when we were graphing, we went to radians. Now I need to type in degrees, so I'm going to go back to my mode button, down to where it says radian, and then go over and click enter on degrees. So make sure your calculator's in degrees when you're typing degrees in. So as we had 400 times the sine of 40. So I just do 400 sine 40, close my parenthesis, divided by sine of 30. Close my parenthesis, hit enter, and you can see that's where I got the 514. And again, I've rounded to the nearest whole number. More example, I encourage you to pause the video and try it on your own now that we've introduced the law of sines. Hopefully you started by drawing your triangle, called it triangle ABC, and then we label what they give me. Angle A is 26 degrees, angle B is 17 degrees, and side length A is 18. Now this time they give me an angle, right? Angle, and then the side. So we had AS, which we also said we would use the law of sines for. But actually, this is a little bit easier, hope you found. Okay, so again, in this case, and it wants to know the side length B, so I would be finding the side length across from it. It depends on what you're trying to find, I suppose. So in this case, I'm going to take the sine of my A, which is 26, over the side length across from it, which was 18, set it equal to the sine of B, which was 17, over side length B, which is what I'm trying to find. From there, you should have cross multiplied. 18 sine 17 equals B sine 26, and divide both sides by sine 26. Hopefully you practice typing that in your calculator, and for this one, you should have gotten 12. Okay, so that's at its most basic level, the law of sines. Whether you're given angle side angle or angle side, you set up those ratios and solve. The only twist we saw is that sometimes you'll have to find the third angle in order to use the law of sines. Now, the third case, SSA, like I told you, it's called the ambiguous case, and we're going to learn why in this example. Okay, the reason it's ambiguous is because you could get two answers, but you don't always. Okay, so this is where it's a little confusing. We're going to start the same as we did in triangle CDE. So I'm going to draw a triangle CDE. They tell me length, so CD, remember that would be the side length CD, is 8 from D to E, that's 6, and the measure of angle C is 30 degrees. Okay, so it asks me what's the measure of angle E to the nearest degree. So far, not too bad. Okay, I would take the sine of 30, I use my law of sines, over the side length across from it, which is 6, equals sine of E, which is what we're trying to solve for, over the side length across from it, which is 8. I would still cross multiply. I get 6 sine E equals 8 sine 30. Next, I would divide by 6 to get the sine E by itself. And now we're back to what you learned in a previous section. Anytime you need to solve for the angle, basically I have to think about how can I get the sine over there? That's inverses. So I would do E equals the sine inverse of 8 sine 30 over 6. Now I'll show you in a bit how to type that into your calculator, but for now, I'm just going to tell you that when I typed that into my calculator, I got about 41.8. So I'm going to say it's about 42 degrees. I'm just going to round it to the nearest whole number. Okay, so I have a situation where my answer is 42 degrees. Here's why it's ambiguous. Oftentimes, I would just stop there. However, one thing that I need to know is that sometimes when it's side-side angle, I could have had the 8 here, the 30 degrees, and you sometimes can actually, rather than swinging that 6 out like I did in my first triangle, it could actually come back and sometimes also work. So every once in a while, there is a second situation where the exact same setup, the 30, the 8, and the 6, could actually make a second triangle. The only time that would happen is if this angle E is the complement to this angle, or supplement, sorry, if they add up to 180. So if there's a second triangle, so I'm going to call this E1 now, and this is E2. If I have an angle E2, I would take 180 degrees minus the first angle I found. Okay, so 180 minus 42. And when I do 180 minus 42, I get 138 degrees. So if I have a second triangle that works, my answer would be 138 degrees. Now, here's the final check you have to do. Check to see if it works or if it is possible. Okay, the way it's possible, remember, the three angles in a triangle equal 180 degrees. Every once in a while, when you find your second angle measure, if you put it into the triangle, it wouldn't work because the three angles would have to be bigger than 180. So your check to see if your second angle works, take the angles you know. We knew the first angle was 30, and we know our second angle would have to be 138. If I add those together, I get 168 degrees. And since 168 is less than 180, that means I do have enough left over for a measure for angle C, so this one is okay. So in the ambiguous case, when you're given SSA, you find your first angle the same. My first angle is 42 degrees. You find the second angle by taking it 180 minus the angle you just found, but then before you circle it as an answer, which now it is an answer, you have to make sure it would be possible. And that means that if you put it into a second triangle, your angles can't be more than 180 degrees. That's the ambiguous case. It has the extra layers of first finding the second option, and then once you have the second option, making sure it's actually okay. All right, let's do another example. So it says in triangle XYZ, so I'm going to draw my triangle XYZ, length of Y, so across from Y is 5, length of Z, so across from Z is 3, and measure of angle Y is 60. Okay, so I want to find the measure of angle Z. This is what I'm trying to find. Okay, so I start with sine of 60 over the side length across from it, which is 5, equals the sine of Z over the side across from it, which is 3. I cross multiply, 5 sine Z equals 3 sine 60. I divide by 5. I get sine Z equals 3 sine 60 over 5. And last but not least, to get the Z by itself, I need to move this sign over. So I take the sine inverse of that whole big ugly fraction. And again, I told you I'd show you on the calculator. I got to do that in just a minute here. But when I typed it in, and again, as soon as I recognize it's the ambiguous case, which I forgot to talk about. Again, if I travel around the triangle, this is a side. They don't give me that angle. They give me another side, and then they give me an angle. So because it's SSA, it's the law of sines, but I need to remember it's the ambiguous case. The reason I forgot to say it is because I showed it up here, but you'd want to test it every time. So when I type that into my calculator, the first answer I get is 31.3 degrees. So that's I've kept it as a decimal this time for some reason. Okay, so that is my situation where it is an acute triangle. But now to find the second option for Z, I would take 180 minus that, 31.3. And so if a second triangle exists, it would have to have a measure of 148.7 degrees. Okay, so the obtuse angle measurement would be 148.7. Well, now I need to check to see if that's possible. The angle they told me was 60 degrees. So I'd have to be able to take the first angle, the Y, that has to be there of 60 degrees, plus this angle, 148.7. But when I add those together, I get 208.7. Well, 208.7 degrees is greater than 180 degrees. That doesn't make sense because those two by themselves are too big for a triangle. So this doesn't work, which means that this triangle doesn't exist. There is only one triangle that has those things. Okay, so the ambiguous case is confusing because we can't even say it always has two options. Okay, all right, let me go back to my calculator and show you how I typed this in, just so that you should have seen this in previous videos and practice, but if I want to do the sine inverse, which is what I wanted, it's right above the sine. So I have to hit my blue second button and then sine. So that's how I get the sine inverse. Now, because I'm doing a fraction, or I don't even need to worry about, but I would do 8 sine 30. Oh, yep. I'm going to double check my mode real quick. It's still in degrees. Okay, just wanted to make sure. So I have 8 sine 30, close my parenthesis, divided by 5, close my parenthesis for the whole thing, and enter. And that's where you can see I got the 53 point. Oh, that was the next problem. Sorry, different problem. That'll be our answer for the next one. All right, the one we just did, sine inverse of, this time it was 3 sine 60. Close my parentheses, and we divided by 5. Sorry about that. Okay, so that's where I got the 31.3 that I found. Okay, but so you can just see you always hit that sine inverse button first. Okay, here's one more example that I want you to try on your own, and then we'll finish up with a couple word problems. All right, so hopefully you drew your triangle ABC. Angle A is 30 degrees, side length A was 5, and side length B was 8. So we want to find the measure of angle B. Now again, I would need to figure out what I've been given. And if I start here, I was given a side length, given another side length, and then an angle, which means this is SSA, which means it is the law of sines, but it is the ambiguous case. Okay, so I need to make sure I check for that second triangle. So to find B1, my first option, I would take the sine of 30 over 5 equals the sine of B over 8. Cross multiply, 5 sine B equals 8 sine 30. Divide by 5, and then I would do sine inverse. So you should have typed in your calculator sine inverse of 8 sine 30 over 5. I accidentally did that a second ago for you, so hopefully you got the same answer, but that's where I got 53.13 degrees. If you just rounded to 53.1, totally fine. All right, so that's B1. Now make sure you read Pearson carefully, though, because they'll always tell you what to round to. So that is an answer. But now, remember, we have to check for B2 to see if a second option works. To find B2, you're going to start by taking 180 minus the angle you just found. So I do 180 minus 53.13. So if I have a second triangle that works, B2 would be 156.87 degrees. Okay, so if it works, that is my answer, but I need to check it. I take that answer that I just got, 156.87, but I would have to be able to take that plus the angle that we know has to be in the triangle. The one they gave me was 30. And that gets me to, sorry, got to check something real quick. I think I got my key wrong. 53. This might not be right. Sorry, I can't find my calculator. All right, so I'm double checking 180 minus 53.13. Okay, my bad. Sorry, my key was right, but this was supposed to be 126.87. The reason I was stumped is because if it was 156, it actually wouldn't have worked because it would have been over 180. But if I would have subtracted correctly right here, it's only 126.87. If I add 30 to that, then I get 156.87. So this one works because 156.87 is less than 180. Okay, So there are two triangles that could have all of these features, and the second one would have that B angle of 126.87. All right, last but not least, we could be given a situation where there's word problems. So in this case, Nicholas is walking around an obstacle course that begins at point X. He starts going straight on the path. It then takes a wide right turn. That's going to be important. Onto a second path and continues for 1,000 feet before turning to the final path. What is the angle between the second path and the final path? Okay, so we can see that this is what we want to find. So we want to find angle Z. Well, we are given side angle, which means I'm using the law of sines, but it also means that it is the ambiguous case. Okay, so in order to do this, I would find my law of sines. So I would do sine of 32 over 1,000 equals sine of Z over 1,200. Gives me 1,000 sine Z equals 1,200 sine 32. Divide by 1,000. And I get Z equals sine inverse of 1,200 sine 32 over 1,000. So Z, when I did that, was 39.5 degrees. Okay, so he could turn 39.5 degrees to make it. That's one option. Now again, I could check to see another option, which would be 180 minus that answer because it's the ambiguous case. So 180 minus 39.5 gives me 140.5. But then when I do that, I would check it, and it does work because I'd have 140.5 plus 32, but that's 172.5. Okay, so yes, it works, but it means that this last angle at Y would only be 7.5. So the only reason this only has one answer is because they said at point Y, this one right here, it has to be a wide right turn. We would not test you on that because it is the ambiguous case. Technically, there's two answers, but the reason 39.5 is correct is because we wanted the third angle to be wider. Okay? All right, last but not least, pause the video, try this one on your own. Hopefully you found that if she's flying her Zeppelin balloon, the string is 90 feet long and the angle of elevation of the ground is 60. Across the park, she's watching the balloon, which is between the two people. The angle of elevation is 75 degrees. How far apart are they standing? So we want to find this. So again, this time we're given angle, side, which is a straightforward law of sines. You should add sine of 75 over 90. The only non-straightforward part is x is what I want to know, which means I want the angle above it. So you should have done 180 minus 75 minus 60, and that gives you 45 degrees. Okay, so that was 45. So I do sine of 45 over x, cross multiply. I get 90 sine 45 equals x sine 75 divided by sine of 75. And my final answer is 65.9 feet. All right, so to summarize, here's what the law of sines talks about. And go ahead and work on your 8-2 day 1 law of sines homework. Thanks.